It began like so many other discoveries in astronomy, not with a flash of light or a booming announcement, but with a faint, silent blip, a motion across the blackness of space so subtle, so precisely tracked, that even the most advanced survey telescopes nearly overlooked it. At first it seemed like a comet, then perhaps an asteroid. But the more astronomers looked, the more this object, cataloged as A11PL3Z, defied easy labels. It was too steady in its path to be a wild wanderer, too fast to be something born in our own solar system. Scientists couldn't help but recall Oumuamua, that enigmatic cigar-shaped visitor from 2017 that tumbled through our neighborhood, sparking endless debates and leaving us with far more questions than answers. But this one? Designated 3I/ATLAS after confirmation, it was different, larger, brighter. And thanks to the James Webb Space Telescope, our sharpest window into the cosmos, we're uncovering details that could rewrite what we know about the building blocks of other star systems. Welcome to the thrilling world of interstellar visitors, where space exploration meets the ultimate cosmic puzzle. Today, we're diving deep into 3I/ATLAS, the third confirmed object from beyond our solar system, and why it's got scientists buzzing in 2025. Stick around as we unpack its journey, its secrets, and what it means for humanity's place in the universe. Imagine hurtling through the void between stars at over 137,000 miles per hour. That's faster than any spacecraft we've ever launched, yet this icy wanderer makes it look effortless. Discovered on July 1st, 2025, by the NASA-funded Asteroid Terrestrial Impact Last Alert System, or ATLAS, telescope in Chile's Rio Hurtado Valley, 3I/ATLAS wasn't just spotted, it was a eureka moment in the making. Pre-discovery images traced it back to June 14th, pulling from archives of Atlas and Caltech's Zwicky Transient Facility. Right away, its hyperbolic orbit screamed outsider. Unlike comets looped around our sun like loyal pets, this one's path is a straight shot through, entering from the direction of Sagittarius, slingshotting past the inner planets, and exiting into the interstellar deep without looking back. Fun fact, its speed at discovery? A blistering 61 kilometers per second, clocking in at about 220,000 kilometers per hour as it nears the sun. That's like crossing from New York to Los Angeles in under 2 minutes. No wonder it earned the 3I tag, the third interstellar object, following Oumuamua and 2I/Borisov. But why does this matter? In a universe teeming with trillions of stars, these rare flybys are like postcards from alien worlds, carrying chemical snapshots of places we'll never visit. They're not just rocks, they're time capsules, potentially billions of years old, hinting at how planets form far beyond our backyard. As 3I/ATLAS coasts closer, its story unfolds like a gripping novel, chapter by chapter revealed through our telescope's unblinking gaze. Let's start with the basics. This isn't some dusty pebble. NASA's Hubble Space Telescope snapped it on July 21st, 2025, when it was 277 million miles from Earth, revealing a teardrop-shaped cocoon of dust enveloping its icy nucleus. Think of it as a cosmic cotton candy machine, solar heat vaporizing ices into a glowing coma and tail. Size-wise, estimates pin the nucleus between 1,444 feet and 3.5 miles across, making it the largest interstellar object we've eyeballed yet. That's potentially 33 billion tons of frozen mystery, heavy enough to dwarf Oumuamua's puny 800-foot frame. And get this, unlike typical comets that puff out water vapor like a steamy shower, 3I/ATLAS is dominated by carbon dioxide, dry ice on steroids. James Webb's near-infrared spectrograph caught this on August 6th, locking in an 8-to-1 ratio of CO2 to water ice, the highest ever recorded. It's like finding a snowball in the Sahara. This composition screams origins in a colder, drier stellar nursery, perhaps from the Milky Way's ancient thick disk, where stars are older and metal scarcer. Short, punchy bursts of activity? Webb and Hubble show jets of gas and dust flaring forward, 10 times longer than wide, scattering sunlight in ways that twist polarization readings into negative territory. Another quirk that has experts scratching heads. Now rewind to those trailblazing predecessors, because 3I/ATLAS doesn't exist in a vacuum. Pun intended. Oumuamua burst onto the scene in 2017, a reddish, tumbling cigar without a coma, accelerating mysteriously via outgassing that some whispered hinted at artificial sails. Then came 2I/Borisov in 2019, the first clear interstellar comet, with a cyanogen tail and familiar chemistry, like a solar system cousin gone rogue. But 3I/ATLAS, it's the overachiever. Bigger, brighter, and more active. It's outshining Borisov by magnitudes and packing more mass than both combined. Here's a quick breakdown to compare. Oumuamua, asteroid-like, no coma, 800 feet long, tumbled erratically. Borisov, cometary with tail, water-rich, about 1 kilometer wide. Minus 3I/ATLAS, active comet CO2, heavy 440 meters to 5.6 kilometers nucleus, elongated dust envelope. What ties them? All hyperbolic speed demons, unbound by Sol's gravity, drifting for eons after gravitational kicks from their home stars. Estimates peg 3I/ATLAS at 3 to 14 billion years old, older than our 4.6 billion year sun, suggesting it hails from the galaxy's formative frenzy, when the thick disk birthed hardy low-metal worlds. It's like unearthing a fossil from the universe's dawn, whispering about exoplanet factories we can only model. And that trajectory, eerily optimized, passing near Mars on October 3rd, Venus later, and Jupiter in 2026, with a slim 0.005% chance of pure randomness. Coincidence? Or just the math of interstellar highways? Diving deeper, the real magic happens in the data deluge from our orbital observatory fleet. NASA's fleet is all in. Tests staring from low Earth orbit, Swift catching X-rays, SphereX mapping infrared from August 7th to 15th. Over at Mars, Perseverance and Curiosity rovers tilted skyward on October 3rd, while the Mars Reconnaissance Orbiter's high-rise camera grabbed high-res shots during the closest approach, just 0.3 astronomical units away. ESA is not sitting idle. Mars Express and ExoMars Trace Gas Orbiter tuned instruments for spectral sweeps, hunting gases and dust. Even JUICE en route to Jupiter's moons will peak in November as 3I/ATLAS heats up post-perihelion. Juno might snag the closest view yet, post-solar flyby, when CO2 boils off like a fizzy supernova. These aren't passive peaks, they're symphony conductors harmonizing data across wavelengths. Early results? A reddish coma from carbon-rich dust, echoing Borisov, but with elevated nickel over iron, flipping typical ratios on their head. It's as if this comet brewed in a stellar forge favoring heavy elements differently. Fun analogy, picture our solar system's comets as apple pies, watery, familiar. 3I/ATLAS, a cosmic key lime, tart with CO2 and zesty anomalies that challenge formation models. Of course, no interstellar tale skips the what-ifs, those tantalizing theories that blend hard science with a dash of wonder. Here's where we label it clearly. These are speculative ideas grounded in data but not consensus, often championed by folks like Harvard's Avi Loeb, the same mind behind Oumuamua's light sail hypothesis. For 3I/ATLAS, Loeb flags 7 quirks that could hint at more than natural drift. First, its sheer bulk. That 33 billion ton estimate screams anomalously massive, tougher to eject from a parent star than smaller siblings. Then the forward jet, beaming sunlight like a spotlight, and that extreme negative polarization, twisting light in ways comets rarely do. Chemically, the CO2 dominance and metal skew, unusual, sure, but explainable by diverse stellar nurseries. The real head-scratchers, its ecliptic plane alignment, 0.2% random odds, planet-hopping path, and arrival from near the 1977 WOW signal's direction, 0.6% chance. Loeb muses, pure theory here, could this be engineered? A probe optimizing flybys for data grabs, official N, ASA, and ESA, firm number, Natural comet behaving as expected, they say, with no hostility or artificial signals. No course shifts, no pulses, just physics. Yet these ideas spark vital questions. If not us, what else slingshots through space? They fuel missions like the proposed Comet Interceptor, ESA's Comet Chaser for future visitors. Remember, speculation drives discovery. It's what turned Oumuamua's oddity into comet science gold. As 3I/ATLAS hurtles toward perihelion on October 30th, dipping to 1.4 AU inside Mars orbit, its legacy is already etching into space exploration's ledger. This isn't a one-off, it's a benchmark. By studying its outgassing, we decode how volatiles survive billion-year voyages, informing exoplanet habitability hunts with telescopes like Webb. Data from Mars assets alone could map dust interactions in real time, modeling impacts on atmospheres. And the big picture? Interstellar objects might be common. Atlas scans suggest one every few years. That ramps up planetary defense too. While 3I/ATLAS poses zero threat, safest at 1.8 astronomical units from Earth, understanding hyperbolic intruders sharpens our asteroid watches. Future implications? Imagine fleets of probes chasing these ghosts, or AI sifting signals for non-natural tweaks. It's timeless. Every visitor expands our cosmic neighborhood, reminding us we're not isolated, but interwoven in a galactic web. As it fades from view by December, re-emerging dimmer in Virgo and Leo, we'll chase echoes in archives, pondering the stars it left behind. So there you have it, the saga of 3I/ATLAS, from subtle blip to interstellar icon. We've journeyed from its Atlas debut to Webb's spectral secrets, weighed its anomalies against solid science, and glimpsed how it reshapes our view of space exploration in 2025. Key takeaways? It's a natural comet, yes, but one packing ancient chemistry that challenges our models, urging us to look farther, dig deeper. What do you think? Harmless wanderer or hint of weirder wonders? Could its path be a fluke, or is the universe winking at us? Drop your thoughts in the comments. I read every one. If this sparked your curiosity about black holes explained or Mars mission updates, hit subscribe for more dives into recent space discoveries. Like if you're Team Cosmic Postcard, and check out my video on Oumuamua's mysteries next. Thanks for exploring with me. Until the next blip, keep looking up. The stars are calling.